We had a client that does a lot of work in industrial floor mats. And one situation that they run into with them is they have an interlocking model for the floor mats so that you can build a large mat out of smaller ones. However, if you cut that in any one place, you lose the interlocking features. So the challenge was to come up with a floor mat that one could cut and still have the interlocking features. Plus a couple of other things that they wanted. They wanted a forklift to be able to be driven over it, and they also wanted it to be flexible enough that they could roll it up for shipment. So the starting point for that was for us to do some preliminary design with some unique features on the back side and with open area and closed area for them to decide what depth of tread they would like, and to have it for areas when they want it to be open for liquids to go through it and closed. And from that CAD work, the computer-aided design work, we then generated a rapid prototype model which allowed the customer to get a sense of what this was going to look like. Once we had that worked out, we then took from that, generated a urethane casting, which then gave us something that had some of the properties that we were hoping to get in a finished unit, so we could get a sense of its flexibility and rigidity and just its basic form. Also, again, we're looking at the opened plus the closed with two different levels of texture in it. From that, it was decided on a depth of texture for the closed one and what the open side should look like, and we went ahead then and generated the molds in order to injection mold these parts. And this is a finished part off of the injection mold. So when the process was done, then we had a commercialized mat that, when cut in certain areas, would still allow for interlocking of one mat to another. It had the flexibility that was required, yet it had enough rigidity to it that a forklift could be driven on it.